Well, good morning or good evening, whatever it is for you. This is the Saturday morning tonic transformed into a Wednesday something tonic. Here we are, live session 8, transformations. And we have enlargement, rotation, reflection, and translation. By my previous calculation, when I made these ahead of time, we are 47 days out from the exam. Best of luck, everybody. Don't let the panic set in. And this is what we talk about at the start of the year. You're going to let that panic set in if we've left that late. You're going to do regular revision, and that will get you through to the end. So if you're here because you're taking your exam next year, well, that's very fortunate. You can learn from this. Time goes really quickly. A little bit every day is better than a panic at the last minute. So just to remind everyone who may be new here, if you want to get these questions ahead of time, stick around at the end of the live stream. You can go over to Patreon and you can get next week's questions ready and have a go at them ahead of time, because that's what it's all about. So yeah, check it out. All the previous ones are there, and let's get started. So I didn't put these in the exact order that you see them in the list, because that would be a bit meh. Transformations are actually really good. In the long term, you're headed towards describing them a bit more sophisticated with matrices. And for now, we need to understand and appreciate what all these three are. I hopefully have found a few representative questions as well as an interesting question. So let's get started. For real this time. A class is making snowflakes from paper. To do this, a square piece of paper is folded in half and then in half again. Then they cut out two shapes from this folded square. As you can see, it's that's a circle and a pentagon. Real pent, not a regular pentagon. And then what happened is this shape gets unfolded. What would it look like if it was unfolded? So this one here is the cutout, okay, and it's essentially going to be folded out twice. Now imagine it folded out once along this line on the right. Can you imagine what that looks like? It's going to be a symmetry. As you can see, all of the designs start with that. So just put this in the corner. Now if these all of these designs were to be folded out to the right, which one is going to give us a mirror reflection? Well, you can see it's B. Essentially, this arrow, call it an arrow if you wish, is facing this way. When it gets reflected, it's going to be equidistant in the opposite direction. So let's use the B, for example. It's going to be equidistant in the opposite direction as it's folded out at the center point there. And then if we take that top part and fold it down, these circles go to these circles. They're the same distance apart. And actually, these will become the same orientation. So we're talking about reflection here. And I think this question is very intriguing. It's more of a question of, can you visualize the transformation in your mind? You notice that the particular solution that we have there is symmetrical, this way and this way, okay? The others are not. As you can clearly see there, that it's not. And over here, if we were to make it symmetrical, it would be B. Okay, so enough time on that question. I thought that was a fun question to add in. I had fun making it. Let me circle B. And maybe I will put in a couple of lines just so we know that it's symmetrical there. Love it. Okay. So a real reflection question. Reflect shape H in the line y equals negative 2x. I had a funny joke, actually, if we call... you'll probably get it if I just say this. Instead of calling the shape H, I called it Optimus. And I'll let that one sink in if you know then you know. Maybe I'll explain later. Reflect shape H. So first of all, you need to know what negative 2x is. So here we're using multiple skills. How does one go about drawing the line negative 2x? There's a really simple way of doing it, which is it's going to work very well for most people when they're sketching. You don't want to do it the long way. I'll give you one option, I suppose. If you've got a calculator with you, you can get a set of points from there just by putting the function in. But the best way of doing it, in my opinion, is set x equal to 0 and y equal to 0. This won't necessarily work for this one because it's going to go through the center point. So all we have to do is pick 2 points that we think are sensible enough to cover here. I know that negative 2x is going down, like for every 2, so every one across, it's going to go down 2. And I also know that it has an intercept of 0 because it's plus 0. Now, if you don't know what on earth I'm talking about, you need to look at linear equations. There's a little bit of a delay in the tablet today, so bear with me on writing. Linear equations are going to allow us, like plotting them, to be able to access this question a bit better. And we know that from doing that sort of lesson, the intercept is 0, so we can put across there. As I said, there's a couple of ways you can put into coordinates. My easy way of doing it is for every 1 across, it goes down 2. That's the definition of a gradient. So every plus 1 in the x, that number, that coefficient negative 2, tells us how far it goes up or down. This goes down 2. So essentially, we're going to go across 1 and then down 2. And I'll just do a little cross to see where we're going. Across 1, down 2. And we'll do the same going in the other direction. We've essentially got ourselves a straight line here. Now, you know what happens when we do this? This sometimes doesn't work. So we will try our best to create a straight line, even if it's over here. And then we'll adjust. Okay, cool. Not awful, is it? And that will do us very nicely. So here's our line that we're going to reflect it in. I think the reason I went for this is because a lot of people don't really like reflecting it when it's on the line. It's like what to do, like it's supposed to flip and go to the other side, right? So how do we deal with it when it's in the middle, when it's sort of going to overlap on itself? Just deal with one side at a time. So all of these lines have to go perpendicular to the actual line itself. So it's fairly tough to do if it's not like obvious, but we're going straight to the line. Now, what does perpendicular mean? Perpendicular in this case, because we have a gradient of negative 2, perpendicular is actually up 1 and 1 across. So let's just make that clear. So if I was to go straight at that line at 90 degrees, it would have to be by going across 2 and down 1. It's not as simple as let's follow the diagonals to the line. I'll show you. If we did that for this, we went to the line there. Okay, you may think that's fine, and then you're going to carry on and draw the line over there. But it's not perpendicular. It's actually not going to be the reflection. So in essence, we have to be aware of what 90 degrees to the line is. And that it's the reciprocal gradient, if you will. So if we have negative 2 as the first gradient, call it M1, then the gradient of the line which would be perpendicular to that would be the negative reciprocal, which is a half. So you could draw that line, and we will just draw it quickly to work with. This is very advanced stuff, so obviously you're here because you've been doing a lot of this stuff and you might want to look for something a bit more. But I'm definitely going to the technical details. Right, let's get a half, because I feel like that was twisted by everything that's going on. Right, let's do it from here. So for every 2 we go up 1, every 2 we go up 1. No, don't do that. All right, let's just keep it like this. As you can see quite clearly, this is definitely 90 degrees to our mirror line. This is the line that we can use when tracing all the way to the line, right? So we're looking for the points. Now, how far is that away from anything is the other thing. We're going to first of all measure to the line, and then we're going to go the same distance on the other side. So let's start with an easy one, which is the bottom vertex. And we could label these so we deal with them a bit. Oh, yeah, I know that's going to happen. Turn that off. We can label them so we could deal with them a bit better. So C down here is this distance, and you can do this with a ruler. I'm not going to do it with a ruler on a screen, but suffice to say I am measuring this. Let's zoom in. Can we zoom in without ruining any integrity here? Yeah. So the distance from C, which is right here, to the line is this distance here, and it's going to be equidistant on the other side. So there's the new C. And we call the new C, C prime, if you will. All the points just end up going on the opposite side than where they currently are. Let's get rid of some of this. There we go. And now we'll go for A. Okay, A is this distance. And if I take a ruler now, so you've got to imagine I've got a ruler, and I'm just going to measure the distance from this vertex to the line, which is, I'll draw another line just to make it clear. I'm measuring this distance. In fact, I could probably show you what I'm doing if I draw using my ruler, and then I can take this line and move it the other side, because that's the exact distance that I'm looking for, right? That's how far away it is from the line. And if I go the other side, that's how far it's going to be on the other side. So we'll make a little mark there for A prime. And you see how this isn't so straightforward, because it has to be perpendicular to the line. So that's why I'm using this negative 2x gradient. Let's get rid of that now. Brilliant. And the last, no, don't do that. The last one is going to be B. Let's move it over to B. Around there. And our line distance, if I put my ruler down, is going to be to there. And that's in line. Just trying to select the correct line here. That'll do. That'll do. And it's going to be that distance on the other side. So we draw a little cross for B prime. Now this looks very strange at first, because what is going on, right? They've got bits all over the place, but all we have to do is connect these new bits up, and then we're good. Now this might be pretty difficult if I have no, I'll keep it. I'll try and do it by hand. Okay, so here we go. Green it is. Make it slightly larger so we can see it. And all of those primes go something like this. See my wonky lines, eh? There we go. And that's it. You can just take a moment and see that the points have just switched sides, and they're equidistant from the other side, and they are all in line. Like if we drew a line between the original point of the object to the image vertex, you would find that they were 90 degrees. They were perpendicular to the mirror line. There we go. Okay, so not such a straightforward question after all, and that's why we love it. How zoomed in am I normally? That's the question. I think about here. So reflection. I want to just take a moment to write that, because in the exam, if you're doing GCSE, the exact word is important. Reflection. If you have to describe it, then you have to use this full word. Okay? Super important. Okay, let's move it on. Describe fully the single transformation that maps shape H to J. I mean, it's not really a reflection. I'm trying to think of a line there that would give it a reflection. But this J would be a bit further down, like it would start here if it was a reflection, I think. Like if J was there, I'd be very suspicious that it was a reflection in a line that went something like that. But it's a bit off. So essentially, we need to think about a rotation point here. Now there is one way of doing it so that you draw a line between all those original points and the new points. You can find the point of rotation methodologically. But I'm just going to find it based on feeling my way around here. So let's say I put it here. This is the premise first. Let's say I mean, let's do one that's definitely not right, and we'll see. So let's say we go straight up to the first shape, and this is our rotation point, and let's say it's 90 degrees, because it looks like 90 degrees, yeah? This shape is going north, and this is now going west. If we rotated this, keeping it the same, that's 3, then this new vertex would be here. And as we can see, it's not quite there, is it? So, can I rub this out without it all going? Yeah. So this is not quite in the right position. So let's tick it back a bit. So if we now go up, let's make this a bit larger as well, because it's getting hard to see. And we've got this sort of L shape now. Now you've got to imagine this L shape turning, and it went up 3 and across. So this is going to go across 3 and down 1. That is a rotation of 90 degrees. And you can see that the same shape, which is the bottom left and the bottom left, that is in the same position now. So yeah, this point works. This, if we label it, this is 0, 1, 2, 3, and we need to label it because we need to define the point. So it says describe fully. So this is going to be rotation, like the full word, and we say it's about a certain point. We found that to be 1, -2. Sometimes I get the strange connection with the Wi-Fi. I don't know if it's distance from the router. By 90 degrees, are we missing something? You probably wrote this too, anti-clockwise. Because if you went the other way, it would be 270 degrees clockwise, but that would be fine too. And there you go. That's how we're finding the transformation that mapped it. So we've covered rotation there. I didn't go for translation. We'll see that in a second, because the shape was in a different orientation. It was not it wasn't any longer facing upwards, so that ruled that one out. And in terms of an enlargement, it didn't get smaller or larger. The only option there would have been a negative enlargement, which is essentially a reflection. So I found the only option there was rotation. And you have to have all those elements to get to score, okay? Rotation, the point at which you're doing it, how many degrees, and which direction. It's the one that you get the most marks, or potentially lost if you miss something. So careful. Okay, shape K is translated by the vector 3x plus 4, 8y minus 5. Point R is on shape K prime. Oh, but going back to the joke earlier, if the original shape, the object, was Optimus, then its image would be Optimus Prime. So that was the funny thing. All shapes should be called Optimus. Shape K, yeah. So here we go. We've got point R is on K and has coordinates 1.56, and the value of x and y. So find the value of x and y if the homologous point on K is -2 minus 1. This just means the equivalent point, something like that. Yeah, like the similar point, the same point. So there's the point on this shape that is the same point, and it's being transformed. Okay, let's have a look then. So shape K is translated. Translation means that you are going to move by a particular amount. Now, this question is a very interesting one, an interesting find. And as I say, when I go on to these lives, I've never done them. So we shall see how it all pans out. It looks very interesting to me, and I always like to leave it fresh. But anyway, a translation is a description of, how fast something is moved. This, as we can see, 3x plus 4, it could be negative, depending what x is. We don't actually know. So let's look at the coordinates. Okay, so a shape has moved from 1.5 to -2. So where is that? You can look at it on a number line. This is the x movement, the point. Okay, so it's gone from 1.5 and it's gone, oh, that was the wrong way to draw it, obviously. It's gone to -2. -1, 0, 1. Okay, that's pretty accurate. You don't need to draw number lines like this, but I just want to visualize it for people. So it's gone left, and as we know in translation terms, that makes it negative. Okay, so let's start setting up what the actual vector has done. It's gone negative, and we know it's gone negative 1.5, 3.5. That's not a small bracket. That's how far it's gone, and then we'll do the same for the y. It's started at 6 and it's gone down to -1. So actually that's gone down as well by 7. So as you can see, this is the actual transformation that's happened. We'll just double check to see we're on the right direction, because that's how mistakes are made. Point R is on shape K prime. So R is on the new shape. See, that's how mistakes are made. R is on the new shape. So this is actually the new shape. Oh, I've gone the wrong way around. See, always double checks, peoples. Actually, it goes from 1, it goes the other way around, right? So -2 goes to 1, so that's 3.5. And then -1 goes to, so that's 7. Okay, so this is the actual vector that maps K to K prime. And R is a point on that shape. And it's translated by this vector, okay? So this vector is being represented by an equation. And it's equal. So in essence, this is the beginning of your vectors / matrix journey in life. You can equate equivalent elements. So let me give you a color. Orange. We never go orange, do we? 3.5 is equal to this element, and 7 is equal to this element. No, we want a different color for sure. Just not got the same impact otherwise. And so we can write them as two equations. 3.5 equals 3x plus 4. We can rearrange that thing. Equals 3x. Is this disgusting? Oh, it's supposed to be a nice good. No, it's fine. It's fine. We could deal with these numbers, right? When the numbers get tough, that shows us we know the method, right? We stick to the methods. We take away 4, we're at -half, that's true. And we follow and we trust the method. So let's consider what this might be. So this is negative either way, and we've got a half divided by 3. And as we know, as a beautiful relationship, if we're dividing, I need to scroll down with the mouse 1 second. If we're dividing by a particular value, it's the same as multiplying by its reciprocal. So here we have half divided by 3, which is the same as multiplying by 1 over 3. So we get negative 1/6. Is that acceptable? Well, let's double check. If it goes into the equation, it should work. So 3 lots of negative a sixth is negative half. Taking off of that is 3.5. It does work. This is the correct value for x. X equals negative 1/6. Nobody said it was going to be a nice number. It is what it is, and we trust the method. And the last one, you could probably arrange it in your head, but because of what I do here, I'm going to do it all thoroughly for you. 8y minus 5. Now we will need to find y, so we're going to have plus 5 to both sides. Again, it's a fraction divided by 8, or at least a mixed number. 12 divided by 8 is 3 over 4. What are you fool? What are you talking about? Not 3 over 4. 3 over 2. And that's 1.5. We can write that next to each other. I prefer fractions, and so do a lot of people. Sorry if that's not you. But there you go. X and Y. What is this about? This is translation. It's just recognizing the fact that, you know, you move from one point to the other. It's an addition of these shapes. These numbers here to get in the X and the Y direction. And it just adds a bit of algebra in there, I suppose. Yeah, not a bad question. Not bad. I've seen better. Anyway, not to be too judgmental. Describe the transformation of shape C such that it would complete the capital letter H in the third quadrant. They always use H in these questions. Why do they always use H? And that's because it's a very easy number to draw with rectangles. So to complete the capital letter H, we'd be looking at, we don't often use purple either, eh? We'll be looking at this, oh, that's not the best. Let's make it a wee bit smaller. Whatever, it's done now. We'll be looking at this. That's what gap we want to fill. This is actually fairly straightforward. We don't want to think about the logic here. What were you thinking? You were probably thinking, first of all, the shape that starts here is too big. And, you know, it is. So we're going to have to make it smaller. So it's most likely going to be an enlargement question. The question is, how do we get the information required for it to fit there? Because we're going to need the point of enlargement. That's the toughest part. We're going to need the scale factor. That's the easy part. So the scale factor is going to be how many times smaller it gets. Well, it's currently 6 in tall, 6 height, and 3 across. So they're now becoming 2 by 1. The scale factor is clearly 1/3. So we can write that now, not that it matters at this point. But it is one of the elements we need. I think we're going for enlargement. So we write the word enlargement. And that is the weird thing about enlargements. You can enlarge it so that it's smaller. It's just their scale factor is going to be less than 1. If we get to 0, like if we get to less than 0, negative it's kind of more of a reflection and a so it sort of flips it and it scales it until you get to negative 1. If you use negative 1, that's a perfect reflection because it won't change the size. You times it by 1, it stays the same. In this case, we definitely want those 2 elements. Okay, so if it's worth 3 marks, this question, we have 2 already. Now we just need to take it home. We need to think, where is the point of enlargement? Typically, if the original object, let's call this O, the object is here, and the enlargement is on the right-hand side, then it's quite typical that the point of enlargement is on the left-hand side and it sort of goes up like this, yeah? That's roughly where we're aiming. But there's a really cool trick. If we connect all of the lines, and I'll draw a straight line and use it. If we connect all of the lines to their equivalent points, oh dear, that's gonna, we can do this. Works well. We connect them to the equivalent points. We're going to find our point because all of those lines that connect homologous vertices, that's a bit of a mouthful, but the equivalent vertices will all go towards a single point, like a star. Check this. Oh my goodness, did I get that? Oh, it's nearly okay. It's nearly good. See? So what I'm trying to tell you, I'm trying to get at here, let's use, what color isn't on there? Orange. No, that's too close. Let's use green. Yeah, green. And the equivalent point, so this point and this point, you see they're in a straight line. And where they cross over here is likely to be the point of enlargement. We have to check with all the others. Yeah, it looks to be like that's going to be the case. So let's just pencil that in. We'll call that point P. And I'll get rid of the other lines. Actually, I'll leave them on there because it's kind of useful. That's one tactic. This is therefore called C prime if we want to be thorough. And our last bit of information is to describe the transformation. Okay, so we've enlarged scale factor about, actually we could say from is okay, from point P, which we are defining. And if this is a 0, then we got negative 1, 2, 3, 4, 5. And negative 1. All right. Beautiful, aren't they, transformations? That, in fact, has shifted a bit. Let me move that there for when I publish the answers. Okay, so transformations are beautiful. There is a matrix that, a matrix looks something like this. You might have seen it around and thought it looks kind of fruity. 1, 1, 0. This is a matrix. There's operations with matrices, so you can solve simultaneous equations like the one you see here. And in fact, your calculator, your Casio FX991 EX model, amongst others, will find the inverse of this. So let's say it's AX equals Y. Doesn't matter, these are vectors. Then if we're going to use matrix algebra, we can apply the inverse of the matrix A that we see there. Let me scroll down a bit. And essentially, to find this row of unknown values, we can find the inverse of A and multiply it by the vector 1, 3, 10. It's a beautiful little thing, and that will set you up for the foundations of data science and artificial intelligence, that sort of thing. Matrices are brilliant. So this calculator does that, but it's all on the road to understanding those sort of things with matrices and what they do and how they transform positions. Anyway, I've probably babbled on because I'm quite excited about where this transformation is taking us in the future. I find that a lot of people don't really give it the time of day. They don't think it's important, but I can promise you it is. Transformations are hella fun. Don't be lazy about drawing them, and they will reward you. Okay, just to remind everyone, you can go to Patreon if you're watching this on the video catch-up, which is most likely considering the amount of viewers here. Because it's just a strange time to go live for everyone. I appreciate that. Then please go to Patreon and you can get next week's questions. I look forward to seeing you next week at our usual Saturday. In fact, let's make it this Saturday. Questions are ready to go. So not long, get onto them quick, and we'll get going on Saturday. And I feel like that's important because of the amount of days left till your exam. Anyway, best of luck. Have a great week, and stay working hard.